Thank you so much for having me. So developmental grapheme color synesthesia is a condition whereby individuals associate letters with specific colors. It can manifest as vertical perceptions projected onto external space or as cognitive associations. So participants will see the colors in their mind's eye or simply know that a particular letter is a particular color. The associations are elicited automatically. Participants are consistent over time. It's a hereditary disorder, not disorder, it's a hereditary condition, sorry, and it has a neural basis. So in terms of the brains of synesthetes, they tend to have increased gray matter volume in areas responsible for color processing, as well as binding of different information of different modalities. They've also got interconnectivity within and across these different areas, which is then reflected in activity of the brain. So they've got increased activity in color areas as well as in parietal areas, as I mentioned, binding. And again, there's more synchrony within the activation of these areas. One of the defining features of synesthesia is the consistency with which individuals report the colors of their letters. So if you ask a synesthete several times what the color of A is, they will say the same color every single time. And as we found out earlier, it's red. So as this feature is seen to be so important that is the sole method of verifying whether someone who says has synesthesia, whether they have it or not. So in Eagleman's test of consistency, participants are first asked whether they experience colors as a result of seeing letters or numbers or both, and depending on what they say, they are presented with the alphabet and the numbers 3 times. And they have to pick the colors for each letter using a color palette which contains around 16 million colors. For each single letter, you get 3 different colors that the participant has chosen, and you can plot these in color space and work out a distance between each of the different colors. And the smaller the distance between those colors, the more consistent the participant is. You then average this across all the different graphemes, and you get a consistency score that will define whether a researcher thinks you're a synesthete or thinks you're not a synesthete. And currently, the cutoff stands at either 1 or 1.43. So it used to be, the normal cutoff used to be 1, but now it's been loosened a little bit because lots of people were basically failing the test. And as we saw earlier in that nice graph by Rothen et al., the discriminative power is better when you actually use the larger threshold. So as well as brain differences, there are other special kind of features related to synesthesia. So synesthetes tend to have better visual and mental imagery. They tend to be better at color discrimination, and this is thought to be because they experience color a lot more than non-synesthetes do, and because the areas in the kind of brain areas related to color are more active. They also are better at memory tasks, which require the associations of different things together, as well as a memory within context. So when trying to work out why synesthesia might age, we can look at those different things that seem to be special about synesthetes and might therefore either give rise to synesthetic associations and see how they typically tend to decline in the brain. So we know there's a plethora of evidence out there that white matter and gray matter tends to decrease as we age. Visual and mental imagery also becomes poorer, so older individuals find it more difficult to activate images stored in their memory. They also find it more difficult to maintain visual images in their working memory. Color discrimination tends to become poorer, mainly because of macular degeneration and yellowing of the lens in the eye, and associative memory and episodic memory also tend to decline. Another reason why we might think that synesthesia ages is because of several anecdotal reports in literature about people who once had synesthesia and no longer experience it. And actually, we do tend to get in our lab quite a lot of emails from older individuals telling us that their synesthesia seems to be disappearing and whether this is a thing. So although we know although we know a bit about how synesthesia develops in early ages, so it kind of the consistency increases as children get older until they've kind of solidified their synesthetic associations, we don't really know much about how synesthesia develops later in life. The one study that has made an important step is one by Meyer and colleagues, whereby they tested 439 grapheme color synesthetes and asked them to pick their colors for every letter out of a color palette of 13 colors. What they found was that older individuals tended to have smaller bandwidths to their synesthesia, so they not only had a lower number of consistent letters or numbers, they also had more consistent no-color responses. So the authors basically concluded that the way synesthesia ages is by letters gradually no longer having colors. They also looked in detail at the kind of colors that older and younger individuals tended to pick and whether there were any differences. And they found that primary colors were relatively robust, so things like red, yellow, and blue kind of stayed the same, whereas more lurid colors like the fuchsia you see, how do you do this, over here, tended to be less prominent in older subjects. Additionally, things like brown, gray, and white tended to increase more with age. So what our study wanted to do is address some of the issues that this study had, in that the sample of synesthetes in this was not randomly sampled. So it's unclear whether prevalence tends to decrease as age gets older, and it's also unclear whether the kind of synesthetes that tend to come forward and kind of reach out to researchers and take part in things and get engaged, whether they form a special kind of synesthete. We know that things like, there's plenty of literature out there to show that synesthetes tend to have a distinct personality style, but it's kind of difficult to know whether your personality style as a synesthete will drive you to kind of take part in research and stuff. So we might be missing a whole kind of section of synesthetes there. We also wanted to take measures of colors with a less limited palette. And the reason for this is because color has many attributes. So color can have luminance, it can have saturation, and it can have hue. So the first one relates to how much white the color, how bright it is. The second one relates to how colorful something is. So it can be drab, or it can contain more of the color within it. And the hue, obviously, is the traditional kind of color attribute that we know as that changes something from being blue to being green, etc. So just to give you an example, here we have a medium chroma or saturation. Sorry, that's supposed to say luminance. So it's a medium luminance, medium saturation kind of teal color. If we were to increase the luminance, we'd get something like this. If we were to decrease the luminance, we would end up with this. But if we were to hold luminance the same as the previous one, but decrease the chroma, we'd get a qualitatively different color. And then if we were to increase the chroma, we again get a slightly different color. And obviously, if we change the hue, it becomes a different color term. So we wanted to look at these kind of color qualities, because if you use, rather than the RGB space that Eagleman tends to use to kind of work out the consistency score, if you use CIE color space, you can get values, continuous values of chroma and luminance, and you can look to see whether there's more or less of them in specific groups, etc. We didn't look at hue because it's kind of, it goes round in a circle, and it's more of a degree, so it's difficult to kind of analyze in a continuous way. So as you can see, the color palette used by Meyer and colleagues kind of doesn't really reflect the variation in color that you can get. So what we did was we got 3,893 people screened with the synesthesia battery by Eagleman. Half of them were female. We had a range of ages from 16 to 92, but we ended up basically having like a sort of bimodal distribution with a lot more younger people. So what we did was we'll split the data in a data-driven way into two groups. So our older participants are not really traditionally classed as old, but they are people 35 and over, and our younger participants are under 35. So when participants landed on the page, they were first asked some health-related questions that we reported elsewhere in a different paper, but then we asked them if they experienced colors when seeing letters or numbers. Participants could say no, and if they did, they would be thanked and they would leave. And if they said yes, they would be asked whether they have colors for letters, numbers, or for both. And depending on that, they were shown the letters of the alphabet and or numbers, or both, 3 times. And we ended up with 3,647 people who said, no, I do not have synesthesia, I do not experience colors. 95 people that said yes and passed the objective consistency test according to Eagleman, so anyone with a score of under 1.43, and 122 participants who said yes but failed the test. The ages differed significantly across groups. I don't know how informative this is, but we did find that the people that passed the test were aged significantly slightly lower than those who said yes but didn't pass the test, and both groups were significantly lower in age than the non-synesthetes. But we first wanted to look at those color qualities and test performance. So is there something about your synesthetic colors that can determine whether or not you pass the test? And we found that actually people who passed the objective test tend to have more luminance in their synesthetic colors and more chroma as well, significantly. We then wanted to look at age and self-report, so basically prevalence and test performance. We found that when looking within the people that were under 35, 6.7% of them said that they had that they experienced colors as a result of seeing letters. Only 1.9% of people over 35 said that they did. When looking within the people that said that they had synesthesia, 46% of under 35s passed the objective test, whereas only 17.6% of over 35s who said they had synesthesia passed the test. And we also replicated Meyer et al.'s finding of a smaller bandwidth as age increases. So we found a negative correlation between the number of graphemes that you report any color to, whether consistent or not, and age. So far, we know that saturated and brighter colors lead to you passing the test, and we know that older people tend to be less likely to pass the test. So we wondered whether there is any relationship between age, chroma, and luminance that might explain older people's likelihood to fail the test. We found that older individuals reported colors with comparable luminance to that of younger people, but they had less chroma, less saturation. So they're brighter. Their colors were less colorful than younger people on average. And we basically wanted to put everything into a regression to see how all the different variables predict test performance. But the problem with RGB space, which is what is used by the traditional Eagleman score, is that it's not based on how the human eye sees color or the brain sees color. CIE lab space, which you can use for getting the information about chroma and luminance, does. So you can see from the pictures the RGB on the left-hand side, sorry, lefts and rights, never get them right. On the left-hand side, the low saturated kind of colors is the same distance as high saturated colors, etc. However, CIE lab space takes into account that certain colors are harder to see by the human eye than others. So what we did was we recalculated our consistency scores and used the delta E kind of distance, that's perceptual. We normalized them so we could get an easy to interpret consistency score from 0 consistent to 100% consistent. So for this particular test, higher larger scores mean higher consistency, and entered everything into a multiple regression with Chroma as a mediator between the relationship between age and consistency. What we found was that, again, if you can see down here, luminance was still positively related with consistency. So the higher the luminance in your synesthetic colors, the more consistent you are. Age was negatively related with chroma. So the older you get, the lower your chroma or saturation in your colors. And chroma was, again, positively related with consistency. So the more colorful your colors are, the more consistent you'll be. However, when considering chroma as a mediator, there was no relationship between age and consistency, basically indicating that the relationship between consistency is fully explained by the fact that as we age, the chroma of synesthetic colors decreases. So the take-home message is that self-report and prevalence of synesthesia in older people tends to be lower than that in younger people. More saturated and brighter colors tend to lead to a higher likelihood to pass the objective consistency test. And older people have less saturated colors, but this is causing poor test performance. So it's not necessarily that participants, older participants, are less consistent. They are, their colors don't become less colorful, and that's causing them to perform poorly. So it's possible that lower saturated colors are harder to remember than higher saturated ones. This is something we're currently investigating with typical individuals. Weirdly enough, there's not that much out there in the literature to suggest, to kind of say anything about color of memory and saturation that's specific enough. It's possible that as colors become more saturated, then they eventually lose, letters eventually lose their colors and the synesthetic association disappears, causing this lower prevalence in older people. A huge take-home message from this is that when determining whether someone is a synesthete or not, you should clearly take into account the kind of colors that they report and also their age. So not only was chroma related to age, but also independently of age, it was also reported. It was also related to test failure. So future directions can include, one thing we didn't get with this study was whether participants were projectors or associators. And we know that there's slightly different brain mechanisms in the two groups of synesthetes. So it would be, it's quite important to kind of look at how the trajectory of aging of synesthesia change is, or whether it's different in the two different groups. We also have to start asking people if they've ever experienced colors as a result of letters, rather than whether they experience them now. I've come across at least 2 people that found out I've got a postdoc doing synesthesia, and they were like, oh yeah, I used to have it as a child, but I don't really remember the letters of the colors. And I've known these people for 2 years, and they never mentioned it before. So, yep, and another kind of nice future direction should include what the causes of these individual differences in things like saturation, luminance, and color. What determines the kind of colors that not necessarily the hues that you choose, but the saturation and luminance. So in one of the studies we've just published, we've shown that personality style correlates with how colorful your colors tend to be. So specifically for that, it was openness to experience. So the more colorful your colors, the more open to experiences you are. So I'd like to thank you for listening, and everyone who worked on the project with us, and our funders.
We do have time for questions. We have phrase. Sorry. I'm gonna go.
Hi, my name is Appaloosa. I took a a brain scan at USC a little over 10 years ago, a grapheme color synesthete. And I've noticed since then that it's getting harder and harder for me to recall what the colors are. So this is a really interesting study for me. However, my other types of synesthesia are either getting stronger or have remained the same. And I'm associated with grapheme color, but I'm projected colors around people and things, and those are still very, very bright.
Yeah.
So it's a very interesting study for me, and I'm sure if I took that test again, it wouldn't be as consistent as it was.
Yeah, that's really good. It's really interesting actually because we're not sure whether all types of synesthesia will decline in the same kind of way. So it's possible, depending on the brain mechanisms and the kind of areas of the brain that kind of underlie the type of synesthesia, that aging might differ across. So I'm not surprised that some of your synesthesias aren't necessarily changing, whereas others are.
I'm going to be greedy here and ask a question myself, okay. I've had progressive deafness occurring since I was about early 20s or such. So I'm at a point now where I need to wear hearing